Hello and welcome. In this video from our animation series, we'll talk about the proportional band of differential pressure control valves, dpcvs, and pressure independent balancing and control valves, PIBCVs. You might remember from the first videos in this animation series that dpcvs are there to maintain a stable differential pressure across a specific part of a hydronic circuit to ensure stable flow and predictable valve authority, even when the total flow in the system or the available pump heads vary. They consist mainly of a valve seat and plug, a spring and a diaphragm. So, what is the theory behind the proportional band? You might recognize the term proportional band from control and automation. In control systems, proportional control refers to a type of regulation where the response is proportional to the difference between the measured value and the desired set point. The same principle applies in dpcvs, but unlike electronic PID controllers, a dpcv relies purely on mechanical balance between spring and hydraulic forces. The further the differential pressure, or dp, deviates from the desired set point, the stronger the valve's response will be. In this case, the force applied to push or pull the valve into the position for correct dp. As the dp approaches the set point, the reaction becomes smaller. Inherent to this functioning is that the dp controller always needs to see an error to be able to act upon it. This error or difference defines the P-band. The P-band is thus the largest deviation you could see while the valve is within the working range from kV-min to kV-max. This means that it cannot hold the pressure exactly at the set point at all times. Let's take an example. The valve is set to maintain 20 kPa. This means that the spring force is set to ensure that it is in balance with the diaphragm force at 20 kPa. If the dp rises to, for example, 24 kPa, the diaphragm force exceeds the spring force, the valve moves towards closed. But it doesn't snap shut, it moves proportionally. If the dp drops, the spring expands, forcing the valve to open again proportionally. The total stroke of the valve will correspond to a certain bandwidth of dp. Example given, 20% around set point. This is the proportional band. The key is to design a valve with a proportional band that's wide enough to prevent overly aggressive responses to pressure changes, but not so wide that it leads to an unacceptable spread in dp and therefore in flow. The spring stiffness, diaphragm size, and geometry of the valve are thus meticulously engineered to ensure stable but responsive dp control. As you can see, a proportional band is both necessary and inevitable. PIBCVs also include an internal differential pressure controller, which means they too operate within a proportional band. That's precisely why a PIBCV can never have an authority of 1. In electronic DP controllers, let's say type TA Smart DP, an extra intelligence comes into place. A well-engineered internal control system and mechanics ensure extremely stable control with a very narrow P-band. Thanks for watching. We hope you found this video informative. You can find and discover many more videos on our Hydronic College YouTube channel.